Now we're going to see how we can use the discriminant to find the set of possible values of k for which this quadratic here has two distinct solutions. So what this is telling us is that there is some value of the parameter k, or some set of values of the parameter k, for which the discriminant of this quadratic equation will be greater than 0, as it has two distinct roots. Remember, if it equals 0, our equation has repeated roots, or one solution, and if it's less than 0, then our quadratic would have no real solutions. Just tidy up that b, sorry. Okay, so if we plug in our discriminant here, we're going to get 4 squared minus 4a, which in this case is k, c. c is all of this last term here, the plus k minus 3. And that is greater than 0. So let's just tidy this up a little bit. So this is the quadratic that we're going to need to solve. We can divide through by 4 to just make our lives a bit easier, and we're also going to bring all of these terms over to this side. So now we have 0 is greater than k squared. Remember, we've moved this over to the other side, so it will be minus 3k. And moving that over to that side, we're going to get minus 4. Okay? Always, when we're dealing with quadratics, rather than thinking of it as multiplying through by minus 1, always think of it as moving each term over to the other side. So we are subtracting 16, adding 4k squared, and subtracting 12k. If you multiply or divide by a negative number when you've got an inequality, it flips this sign. If you think of it as moving the terms across, however, you're much less likely to make mistakes and end up with your sign pointing the wrong way later on. Okay, so we've added all of these terms over to here. And now we're going to factorise this quadratic. So we've got k minus 4 and k plus 1. A quick check. They do multiply to give me minus 4, and they do add minus 4 and plus 1 to give me negative 3. So we've not solved a quadratic like this before. We have a less than 0 sign. So I'm just going to use the previous videos to help me sketch this. I know that this equation has roots at minus 1 and at 4. So if I just sketch what that quadratic would look like, it would look like that, roots at minus 1 and 4. Now all I need to do is look at this, and I'm interested in the set of values for which my quadratic is less than 0. So that's all of these values here. We notice it's below the x-axis. That is where the quadratic equals 0. Anything below that, it will be worth less than 0. So what that tells us is that this original quadratic will have two distinct solutions when this inequality holds, and that inequality holds whenever k is greater than minus 1 and less than 4. We've found the set of values for k for which this quadratic has two distinct solutions, and we've solved a quadratic inequality using our sketch to help us.